Alright, so we looked at similar polygons. Now we're going to look at more specifically, like usual, triangle similarity. Back in semester 1, we looked at triangle congruency where we had all those shortcuts. We had side angle side, we had HL, we had angle side angle, all that. With triangle similarity, we actually only have three. We have angle angle, we have side side side, and we have side angle side. So those are the only ones you're in charge of knowing. There are no more coming after this, I promise. But we want to be able to use these to prove that triangles are congruent. So we're going to use those similar shortcuts and then use those shortcuts to find some missing angles inside. So a little review. First of all, there are two attributes that we need to be true for polygons to be similar. One is that, let me write this again, corresponding angles must be congruent. That was the same as it was back in triangle congruency. The sides must be proportional though. So corresponding sides shouldn't be the same. We want them to be proportional. Okay, so that's the difference between congruency and similarity. The sides have to have some sort of ratio that matches up when we go through these. So the first shortcut we're going to look at is angle angle. Triangles are similar when two angles of one triangle are congruent to two angles of another triangle. So, look at a couple of examples. Name the similar triangles and mark their congruent angles. Okay? So, what we've got going on here is we have two parallel lines that comes in, cut by a couple of transversals. One here, and then one back here. So what this actually does is it creates alternate interior angles, there and there, there and there. We also have vertical angles. So we have really three A's. We only need two, so that's all we need. So that's AA, and we're going to say that triangle, now this is where you need to be really careful. Triangle P, we could go, oops, I should really mark that as three things here. Triangle P, Q, T we'll call it. That doesn't matter as much. But now you need to make sure you matched up exactly. So P has one of the arcs, R has one of the arcs. So you need to match R and P up. Q goes with itself, and then S would be the other one. And again, that's by angle angle. So you just need to be careful with that when you go through them. Looking at B, we have rhombus, K-A-T-S. Just in a rhombus, we know that it's really a parallelogram, so we have two sets of parallel sides. So we really have the same thing going on again. Parallel line cut by a transversal. So if this is 40 degrees, so is this. If this is 100 degrees, opposite angles are congruent. There's our two A's. And again, make sure you have all your angles marked congruent that you need to. So we know that this angle is congruent to this angle. We know that these two angles would have to be congruent. And then these two angles have to be congruent. So again, matching it up, it doesn't matter what order you go in, but you want to make sure everything is matched. So we could go ahead and say that triangle KTA, I guess I'll say, is similar to triangle, and now you have to be careful again. K has one arc, so it has to go with T for your other arc, and then we went from K to T to two arcs, so T to K, and then we had A has to go with S. And again, that's by angle angle. So you just have to be really careful as you go through and match those up. So that's angle angle. Next one we have side angle side. Triangles are similar when two sides of one triangle are proportional, not congruent, to two sides of another triangle, and their included angles are congruent. So again, the angles still have to be congruent. If they're not congruent, it changes the shape of the shape, basically. SSS is going to be when triangles are similar when the three sides of one triangle are proportional to the three sides of another triangle. Okay, so we'll look at an example of each one here. And this is no real easy way to go through these particular problems. So you got to be pretty careful and really have to think about what you've got. So what we have here is two triangles. So we have this triangle. Let's see if I can outline it. And then we've got this triangle. I don't want to use purple, that shows up. Okay. So we have these two triangles. We want to identify the similar triangles and determine which postulate was used. Show work to support your answer. Okay. So what are we looking at? Well, we want to see right now, since we're given three sides, we want to try and use SSS. That would be the goal here. So if we match these up, the easiest way to do this is, again, to redraw one of the triangles. So I'm going to redraw that green triangle. And it's kind of turned so that 6 is here, 6 is here, and your 9's there. So it's really just turned down so that Q and R match up, and then P matches up with P, and S matches up with that other side down there at R. So what you've got here is that you have 4 to 6, you have 4 to 6, and then you have 6 to 9. So what we've got is 4 over 6 equals 4 over 6 equals 6 over 9. We want to make sure all those ratios are the same, because if they are, we have proportional sides. 4/6 can be reduced to 2/3. 6/9 can be reduced to 2/3. So these sides are all proportional to each other. So all we need to do is finish by saying that triangle, and again we want to be careful with this, let's label everything. This should be P here, this should be R here, and then this should be S here. So we're going to say triangle P Q R. I'm going to say the smaller yellow one is similar to triangle, and it would be P R S because they match up. Okay, so that's that one, and again, it's by side angle, or side. I'm thinking ahead, because we have three proportional sides. 4/6, 4/6, and 6/9 are all reduced to 2/3. Looking at the next one, okay, let's see what we have here. We know we have two triangles. We have one, I'm going to use just the pen this time. We have that triangle, and then we have this bigger triangle. Okay, so we want to see what we can do here. I'm going to go ahead and redraw the bigger triangle below. That's going to be MJN. Now your sides, MJ is going to be 4 plus 2 or 6. JN is 3 plus 6 or 9. Okay, and now I'm just going to get rid of this bottom triangle. I don't really want to look at it because it's too much is going on. Okay, so right now we've got 2 matches up with 6, and we've got 3 matches up with 9. Let's see what they've reduced to. 1/3 equals 1/3. So we have two proportional sides. We only have two S's. We either need another S or an A, depending on what we want to use. What we also have here is an included angle that's congruent in these triangles. Right here, that angle was shared, so it's got to be the same for the small triangle and the big triangle because it's the same angle. So that's where our third letter comes from, so we're going to go ahead and say that triangle, I'll call it KJL, is similar to triangle, and now you'd have to go MJN. Notice how that J angle is shared by side angle side. And again, there's not really an easy way to go about this. There's no formula for working through these. You just got to kind of work through them. That's why we're going to spend 2 days on this and 2 videos on this kind of material. Okay, let's look at a couple more. Finding lengths in similar triangles. So again, make sure everything's matched up. B goes with G, O goes with R, Y goes with L. So I'm going to redraw this triangle over here and make sure everything matches up, and that makes everything a little bit easier. So B needs to go with G, so B's up here. O needs to go with R. So O is right there. And then Y needs to go with L. So OY needs to be 2. OB needs to be X. BY needs to be Z. And again, I'm just going to get rid of it. I don't need it anymore. Okay? So now what we're going to do is set up a proportion like we've worked on before. Find X and Z given BOY is similar to GRL. Okay? Well, one proportion, I'm going to go for X first. We could say something like 10 over X, those match up, is equal to 5.2 over 2. Okay, that'd be a setup to find X. Okay. Setup to find Z, you'd have to do something a little bit different. So I'm going to go ahead and do, let's see, 11.3 over Z equals 5.2 over 2. Here's our constant. We know that's our scale factor to go from 1 to the other, 5.2 to 2. So we're going to use that both times. It's just now matching up with your other parts. Again, there are several ways you can set up these proportions. Go with whatever works for you guys. I'll let you guys go ahead and cross multiply those and finish those. So work ahead and I'll write down your answers here in a second. So we have, let's see, 20 equals 5.2x. So I'm going to take 20 and divide by that. I cannot do that in my head. So 20 divided by 5.2. That's going to be a nasty number. 3.85 we'll call it. So x equals 3.85. There's x. To find z, same idea. So 11.3 times 2 is 22.6, and divide by 5.2 is going to give us, what does that come out to be? 4.35. Alright, so kind of putting everything together over the last couple of days, what we've done. First, we're going to identify the similar triangles, so that'll be part A. Alright, well, we got to prove that they're similar triangles first by some shortcut. So again, you have AA, SSS, SAS. Okay. We have parallel lines cut by these transversals here. So we know that these angles are congruent. We know that these angles are congruent. That's all we need. That's fine. Okay. We have two angles congruent. We can use AA. So, oops, I should label that as a letter A. So identify the similar triangles used. Alright, what you might want to do here again is go ahead and redraw everything. So, I'm going to redraw the small one because it's going to be less. So again, these angles would be vertical. So if I go ahead and redraw the smaller one, it's going to look like this. E goes with H, F goes with J, and G goes with G. So EG is 2x minus 2, FG is x plus 9. Okay, now I can get rid of that. I don't need that anymore. So again, my first step, step A, identify the similar triangles. So I'm going to say that triangle FEG, that works, is similar to triangle JHG. By, we already said, AA. Now we're going to go ahead and get into some of the math part here. Solve for x. So to do this, what we want to do is set up a proportion. So I'm going to say x plus 9 over 20 equals 2x minus 2 over 15. That's just one that works. Use parentheses. So we have 15 times x plus 9 equals 20 times 2x minus 2. So you get 15x plus, let's see, that's going to be 135. Double check that. Yep. Equals, again, distribute 40x minus 40. So we get 135 equals 25x. And again, now it's just your algebra from here. So we have 175 equals 25x. So x is going to be equal to 7. Okay, so we have part C, x is 7. Only thing we have to do in part D is find out what the scale factor is, or the similarity ratio. Well, let's see what we've got going on. If we plug in 7 plus 9, that's going to give us 16 here. If we plug it in here, 2 times 7 is 14. 14 minus 2 is 12. In other words, our similarity ratio, or our scale factor, is 16 matches up with 20, 12 matches up with 15. Either one you take, you're going to get the same thing. 16 over 20 equals 12 over 15. If you reduce both of them, you're going to get 4 over 5, 4 over 5. So, in other words, your scale factor or similarity ratio is 4 over 5. Okay? I know it's a little bit longer video, but again, this is some tougher stuff, kind of working through it. Moving on, looking at the next one. Same kind of idea. Let me split this up so we don't get confused what's what. I'm going to redraw the big triangle again, because that's what usually helps see things. So this is going to be R, W, E, and that means WR is really 8 plus an X, or X plus 8, and down here we have 18. Okay, so we don't really need this. Well, we might need it to see a little bit of it, so we'll see what we have. Okay, so that's what we've got. To prove that these triangles are similar, we need one of those shortcuts. So we could either use AA, SSS, or SAS. So what we have here, pay attention to these parallel lines. Okay, parallel lines cut by this transversal. You have corresponding angles there. You have corresponding angles here. There you go. That works right there. That's two A's. You can use angle, angle. So, again, first step, we're going to say that triangle WAN is similar to triangle WRE. That's one that would work. By angle, angle. You could have also said that W is congruent to itself. That would have worked too. Part C, that's where we're going to get our math involved. So, again, your setup's not too bad with this part. We have to compare these sides. So, this x is going to go with x plus 8. So, x over x plus 8 equals, and then here we have 10.5 over 18. So we have to cross multiply. 18x equals 10.5 times the quantity of x plus 8. So we get 18x equals 10.5x plus 10.5 times 8 is going to give you 84. Subtract both sides. Not that. Subtract 10.5x from both sides. And we have 7.5x equals 84. Divide both sides by 7.5. And we get 11.2. There's your x. Okay. And then D, again, to figure out the scale factor, we're going to plug it back in and use it. So this would be 11.2. This would be 11.2 plus 8 is 19.2. So all we have to do is set up some sort of scale factor here, and it's not going to probably work out too nicely. We have 11.2 over 9.2, 19.2 rather. We also have 10.5 over 18. This is really where your math frac is going to help you guys a lot. So if we do either one, we're going to get 7 over 12. 7 over 12. So there is our similarity factor, or similarity ratio, or scale factor. Okay. So all 4 steps kind of combine in the last couple days of things. Let's look at number 6, and then we'll save. Actually, maybe we'll save 6 and 7 for tomorrow in class. This is a little bit tougher, so I want to maybe, if you want, you can work ahead with these. Number 6 is a little tricky. 7's not too bad, but 6 is a little tricky. So maybe we'll do 6 and 7 tomorrow together as a class. I know we are already running over 20 minutes, so make sure you have 1 through 5 done. We did all those together. Then 6 and 7 you can work ahead, and we will do the rest tomorrow together. See ya.